During our second year of physical measurements degree, we had to carry out a distributed project in September 2020. Having the necessary skills to carry out this project, we decided to choose the laser piano project. This project intrigued us a lot because it brings together notions of the physical measurement technician, such as optics, sensors, programming, acoustics, and signal processing.
The main context of the project is to make a piano using optical processes to allow, like a piano or a synthesizer, to hear notes, but without contact. That means without touching anything except a light beam, and output this sound through a loudspeaker. We can also compare our project with the already existing projects, such as the famous laser harp by electronic music composer Jean-Michel Jarre.
The sound emission is controlled by his hands, which interrupt the transition of the laser beams. This triggers an event transmitted to a synthesizer to create the desired sound. During the first months of research, we were directly interested in the different sensors to choose to set up the project. On the one hand, one laser for each note of a range, therefore 7 lasers, as well as a receiver for each laser. We first took the necessary steps to integrate photodiodes into our installation before realizing that it was easier to integrate photoresistors because these sensors require fewer additional components. Indeed, each photodiode needed 2 amplifiers to operate, so 14 operational amplifiers and their power supply in all. That's huge!
Once operational with the basic component, we decided to start doing tests and simulations. In parallel, we wrote the program allowing to control a signal output node on an Arduino card on the Tinkercad software. After that, we performed a test with a signal laser for a signal node. A loudspeaker was connected to installation and the microprocessor programmed according to our need. A sound is emitted when the beam is cut.
After presenting the simulation to our teacher, he validated the process for us but imposed a duress, the number of lasers. We therefore had to find an alternative to multiply a single laser beam into 7 beams for each knot. After research and discussions with the teachers, we decided to use an optical grating to diffract the ray.
We had to calculate the distance between the grating and the base of our installation, so we did the necessary calculations to size our system to fit in the grating to be portable. Subsequently, we sized the installation in 3D on the same software as the program in order to get an idea of this shape. We used the modeling of start building the installation completely in wood. It was really fun.
After building this wooden frame, we had to look at the electronic part of the installation. At the beginning, the goal was to plug in a battery to power the installation. We did it, but the battery was not delivering enough voltage to power the system. The solution was therefore to connect the system to the power supply using a 9 volts adapter.
This is the final project. We had to connect a switch, a speaker, the optical grating who receive the beam of laser, and under cover we have the two Arduino cards, and this is the 7 photoresistor.
This is the final result of our piano. So, like we can see, this is the 7 notes. So, it was really fun to do and we loved working on this project. It talked to me! It talked to me! So, this project allowed us to manipulate the concept seen in class in particular in electronic and optic parts. And thanks for watching.